The telescope lied to you, and every scientist who looked through it believed the lie, not because they were careless, not because they were wrong about the data, but because they made an assumption so fundamental, so invisible, that nobody thought to question it. That assumption is the foundation of modern cosmology, and it might be completely backwards. In 1929, Edwin Hubble made an observation that changed everything. Galaxies were moving away from us, every single one of them, in every direction. And the farther away they were, the faster they were moving. The conclusion seemed obvious. The universe is expanding. This became one of the most celebrated discoveries in the history of science. It led directly to the Big Bang Theory. It reshaped our understanding of time, space, and the origin of everything. But here is the question nobody asked. How do you know the galaxies are moving away? Because the light reaching us is stretched, redshifted. The wavelength is longer than it should be, which means the source is receding. This is called the Doppler effect. You have heard it with sound. A siren gets lower in pitch as it moves away from you. The same principle applies to light. So the galaxies must be moving away, except there is another explanation for redshift that produces exactly the same data, and it does not require the universe to be expanding at all. To understand this, you need to think carefully about what redshift actually measures. It measures a change in wavelength, a ratio, a relationship between the light that was emitted and the light that was received. Now here is the critical question. What if the wavelength did not stretch because the source moved away? What if the wavelength stayed the same, but the thing measuring it got smaller? If you shrink the ruler, everything measured by that ruler appears to grow. The measurement changes, the ratio changes, the redshift appears, but nothing in the universe actually moved. This is not a trick. This is basic mathematics. The two interpretations, an expanding universe and a shrinking observer, are mathematically equivalent. The equations work either way, the data fits either way, and yet for nearly a century, every textbook, every lecture, every documentary has presented only one of them as real. Leonard Susskind, one of the most respected theoretical physicists alive, has spent decades working on the nature of space and scale. His work on holographic principles and string theory touches directly on this question. The deeper you go into fundamental physics, the more the question of scale becomes unstable. What does it mean for something to have a size? Size is always relative. A meter is only meaningful in comparison to something else. An atom is only small in comparison to the things we use to measure it. If the fundamental constants of nature, the things that determine the size of atoms, the mass of particles, the strength of forces, were slowly changing over time, we would have no way to detect it directly. Because every instrument we use to measure the universe is made of the same atoms that would be changing, it would be like trying to measure whether you are shrinking by using a ruler that shrinks at exactly the same rate. The ruler would always read the same, but the measurement would be meaningless. This is where it gets genuinely unsettling. The standard model of cosmology assumes that the fundamental constants of nature are constant. That is almost literally in the name. They do not change. They have never changed. They are the bedrock of physics. But this is an assumption, not a proven fact. There are physicists who have spent careers looking for evidence that the fine structure constant, one of the most fundamental numbers in physics, might be slowly drifting over cosmic time. Some studies suggest it might be, others say the data is inconclusive, the debate is ongoing. But here is what nobody in the mainstream conversation acknowledges clearly enough. If the constants are not constant, if the size of atoms has been slowly changing over billions of years, then every measurement we have ever made of the universe is contaminated. Every redshift calculation, every distance estimate, every age calculation based on the expansion rate, all of it assumes a stable ruler, and the ruler might be melting. Fred Hoyle understood this problem. Hoyle was one of the most brilliant and controversial physicists of the 20th century. He is the man who coined the term Big Bang, and he meant it as an insult. He spent his entire career arguing against the expanding universe model. His alternative was not a static universe. It was something stranger. He proposed that the universe might be understood through what he called conformal geometry, a mathematical framework where The overall scale of the universe is not physically meaningful, where expanding and shrinking are not opposites, but the same thing described from different reference frames. In conformal geometry, you can describe the same physical reality in an infinite number of ways depending on which scale you choose as your baseline. Choose the galaxy as your baseline. Everything else shrinks. Choose the atom as your baseline. Everything else expands. Neither choice is more correct than the other. They are both valid descriptions of the same universe. Hoyle was largely dismissed during his lifetime. His models had problems. His personality made him enemies. And the evidence for the Big Bang accumulated in ways that were hard to ignore. But the mathematical framework he was reaching for did not disappear with him. Roger Penrose picked it up. Penrose is arguably the greatest living mathematical physicist. He won the Nobel Prize in 2020 for his work on black holes. He is not a fringe thinker, he is not speculating wildly, and he has spent the last 2 decades developing a cosmological model called conformal cyclic cosmology. In this model, the universe goes through infinite cycles. Each cycle ends and a new one begins. And the mathematical transformation that connects one cycle to the next is conformal. It preserves angles and shapes, but not sizes. In other words, scale is not physically meaningful at the boundaries of cosmic time. Penrose is not saying the universe is not expanding. He is saying that expansion and contraction are the same physical process described from different mathematical perspectives. The universe does not care which one you call real. Only you do. Now stop and think about what this actually means. If scale is not fundamental, if the size of things is always relative to some chosen baseline, if the expanding universe and the shrinking observer are mathematically equivalent descriptions, then everything you have ever been told about the size of the cosmos is a choice, not a fact, a choice. When someone tells you the universe is 93 billion light years across, they are not describing an objective property of reality. They are describing a ratio, a relationship, a number that depends entirely on the unit system they chose to measure it with. And that unit system is built on assumptions about the stability of atoms that have never been fully verified across cosmic timescales. You have been given a number and told it is the size of everything. But size is not a property of the universe. Size is a relationship between the universe and the thing measuring it, and the thing measuring it is you. Here is the thought experiment that makes this concrete. Imagine you wake up tomorrow and everything in the universe has doubled in size. Every atom, every galaxy, every ruler, every wavelength of light, every unit in every measuring instrument. Would you notice? No, you would not, because you doubled too, because the ruler doubled, because the light doubled, because every ratio, every relationship, every measurement would be identical to what it was before. Now run the same thought experiment in reverse. Imagine everything halved, including you, including every instrument you have. Again, you would notice nothing. Now run it slowly over 14 billion years. If the fundamental scale of matter has been slowly decreasing since the beginning of time, the universe would look exactly like it does if matter were stable and space were expanding. The light from distant galaxies would be redshifted. The farther the galaxy, the more time the light spent traveling, and therefore the more the scale changed during transit, and therefore the more redshifted the light would appear. The mathematics is identical. The universe you think is expanding might simply be the universe as seen by an observer who is getting smaller. This does not mean the Big Bang did not happen. Something happened at the beginning of time. The evidence for an early hot, dense state is overwhelming. The cosmic microwave background radiation is real. The abundance of light elements matches predictions. The large-scale structure of the universe fits the models. But the interpretation of what happened and what has been happening since depends entirely on the reference frame you choose. And the reference frame you have always been given, the one in which you are a stable observer watching a universe grow around you, is one choice among mathematically equivalent options. It is the choice that feels most natural, most intuitive, most human, which is exactly why you should be suspicious of it. Human intuition was not calibrated for cosmic scales. It was calibrated for savanna survival, for finding food, for reading faces, for throwing objects accurately. The universe does not care what feels natural to you. So what are you left with? You are left with this, the most celebrated discovery in the history of cosmology, the discovery that the universe is expanding is built on a measurement, and that measurement assumes that the thing doing the measuring has always been the same size. That assumption has never been proven. It cannot be proven from inside the system being measured, and the mathematics of fundamental physics does not require it to be true. You have spent your entire life being told you are small, that you are a speck on a pale blue dot, orbiting an unremarkable star in an ordinary galaxy among hundreds of billions of others in a universe that stretches 93 billion light years in every direction. But that story requires a fixed ruler, and the ruler is made of atoms, and nobody has proven that atoms stay the same size across 14 billion years of cosmic time. The telescope showed you something real, but the story you were told about what it means was always just one interpretation, and the other interpretation puts you somewhere very different. Not shrinking into insignificance inside an endless expanding void, but holding still while something else does the changing. The universe did not grow around you. You just stopped being as large as you once were. And the telescope, faithful instrument that it is, recorded exactly what it saw. It just never told you which direction the change was moving in. Neither did anyone else.